Question number 2 is essentially the reverse of question number 1 in that they're giving you the graph and asking you to write the exponential equation. Again, it's worth noting that the structure of the exponential equation is y equals a times b to the x. So that's the structure that we're expecting in all of our answers, which means we need to know the value of the y-intercept and we need to know the value of the multiplier to be able to write our equations. If I look at letter A, I can definitely tell that the y-intercept is at 0.7. So the initial value, or the y-intercept, or the a value, you can call it whatever you want, is definitely going to be a 7. Now the multiplier I'm not so sure about, only because they didn't exactly give me 2 consecutive terms where I could see what the numbers are actually multiplying by. So I'm just going to quickly set up a table and use some of my sequence skills to see if this can help. I have 0, 7, I have 1, I have 2, I have 3, 56. Those are the only 2 points I know. But let's see if we can hypothesize quickly what a good multiplier could be that helps me figure out the pattern. It must be a relatively small number to multiply by, because like if I do 7 times 5, for example, 7 times 5 is 35, but 35 times 5 is way bigger. That's going to be 175, and that's too big. So I need to think smaller. 7 times 4 is 28. 28 times 4, oh, that's already 112. That's too big. So thinking smaller, 7 times 3, no, that's too big. 7 times 2. 7 times 2 is 14, times 2 is 28, times 2 is 56. So it actually looks like times 2 would work as a multiplier. And that means by inference then I can assume that the multiplier is 2. So now that I know the multiplier and I already knew the initial value, I have enough information to make my equation. Y equals initial value 7 times multiplier of 2 to the power of x. Sometimes you get lucky and you get a problem where the multiplier is really obvious. Sometimes a little table of values helps so you can figure it out. We'll do one more. We'll do letter B. Again, same idea. We want y equals a times b to the power of x. So let's see what we have. It is clearly labeled for us again that the y-intercept is 40. So I know for sure that the a value is 40. Not so sure about the multiplier, but I can make an inference. It looks like 0 and 40 is definitely a point, and to the left of 0, which would be -1 as a coordinate, that's our 120. So even though it's a little unorthodox as sequences go, we can certainly tell that the multiplier is 1/3, because 120 to 40 is dividing by 3, which means the multiplier of 1/3. This was kind of nice because they gave us 2 consecutive terms. We didn't have to guess and check any multipliers. It was pretty obvious just by looking at those 2 terms right there in order. So my equation would be y equals initial value, or y-intercept, of 40 times multiplier of 1/3 to the power of x. Most of the questions that you'll see like this are either going to give you enough of a clue that you can make a quick table and figure out the multiplier, or it'll be obvious just by looking at the problems. I like the table of values though. I think it helps me sort my thinking, so I'll kind of let you decide. Question number 3 is also really similar. It's asking you if you graphed this thing and it's giving you the y-intercept and the initial, or the multiplier, which of these points would be closest to the x-axis. These choices are x coordinates of points. So that is not a terribly difficult question if you know what the graph looks like. And my suggestion for number 3 is simply make a sketch. Basically, if you treat number 3 like you would have done for number 1, this is going to be a nice, easy visual question. There's nothing to solve. There's nothing to do. So finish through number 3, and then once you feel like you've got a pretty good handle on the structure of an exponential equation, you'll be ready for number 4.